Today we will be starting with chapter 21 of your maths book, that is trigonometry. Right? You have done the basics of trigonometry in class 9, if you remember. Right? First, let's brush up our basics. So these are the formula that you have to remember for this chapter. Okay. So the first one is known as the reciprocal relationship. Okay. Let's move on to the next slide. This is known as the quotient formula. So there are only two. Tan theta is equal to sin theta by cos theta, and cot theta is equal to cos theta by sin theta. Please write this also. And then the last one, the squared relationship. Okay. So from this formula we get two formula. So the main formula is this: sin square theta plus cos square theta is equal to 1. So if you shift cos square this side, then what do you get? Sin square theta is equal to 1 minus cos square theta. And if you shift sin square that side, then you get cos square theta is equal to 1 minus sin square theta. So this is the master formula, and from this we get two different versions. You have to remember all the versions of the formula, okay? Please copy it down as well. Then similarly, we have 1 plus tan square theta is equal to sec square theta, and two versions of the same formula. Okay. Notice here how 1 and tan are together and sec is separate. In the previous one, sine and cos were together. The two trigonometric ratios were together, and this was on the right side. 1 plus cot square is equal to cosec square. So it's very similar to the second one. To do the questions on this chapter, the first and foremost thing is that all the formulas should be in your head. Okay. So now that paper that I told you to tear out, imagine that is your brain. And for now, you can refer to that page for the formula. Alright. Let's see question number 2. Fast! Okay. Let's see question number 2. We have 1 upon tan A plus cot A is equal to cos A sin A. When there is no plus or minus between two trigonometric ratio, means there is multiplication, right? We know that. How I like to do these questions is, forget about how they are ordered. First, think about this. What trigonometric ratio do we have and what trigonometric ratio do we need? Okay, very simple. What we have, what we need. So what trigonometric ratios do we have? Tan and cot. What do we need? Cos and sine, right? For easy questions, you can convert the trigonometric ratio directly into what you need. Like tan and cot, can I convert them to cos and sine? Look at the formula chart. Can we do it? Is there any formula that converts tan and cot directly to cos and sine? Quotient form, right? So we'll use the quotient form formula. So write very carefully, okay? Tan theta. Tan theta is what? Oh, sorry, tan A. Tan A is what? Sin A by cos A, plus cot A is cos A by sine. We needed cos and sine. We somehow have cos and sine. Obviously, it looks nothing like the right hand side, but at least the trigonometric ratios are same. Alright. Then from here, what do? We simplify. Right. So let's simplify this. Obviously, what should we do in the denominator? LCM. So let's take LCM. What will be the LCM of cos and sine? Yeah, cos A times sine A. Right? And then on the numerator we'll have sine square A plus cos square A. If anyone does not understand this, please let me know. Cos A sine A will go up, so you'll have cos A sine A, and in the denominator we have sine square plus cos square. But sine square plus cos square is 1. So anything divided by 1 is the same thing. So cos A times sine A. which is nothing but the right hand side. Proved. I'm assuming your basic maths is fine. So if you don't understand anything, feel free and ask me. Which line do you not understand? Yes, Raghav.
1 divided by 10 square.
Which one?
1 divided by.
This one. So you see, this is the main division, right? On the numerator, we have 1. So it is 1 divided by this part. Okay. This part, we are solving it and taking LCM, and we end up with this. So how do you do this? See, you look at the denominators. The denominators are different, cos A and sin A. So when the denominators are different, the LCM will be the product of the denominators. Means this into this will be the LCM. So you got how we got the LCM? Then what do we do with the LCM? Whatever is the LCM, we divide by the denominator, multiply with the numerator. Okay, I repeat. Whatever is the LCM, we divide by the denominator, multiply with the numerator. So cos A sin A divided by cos A will be how much? See, cos A sin A divided by cos A will be how much? Very good. We can cancel and we end up with sin A. So we got sin A after dividing. Whatever we got after dividing, we multiply with the numerator. So sin A into sin A will be sin square A. Okay, there's a difference between sin A square and sin square A. So you got this. Similarly, cos sin divided by sin will be how much? Very good. Cos A into cos A will be cos square. You got how this worked? Okay. After that, sin square plus cos square is 1, and this goes up. Okay. Anyone else who did not understand? Everyone got it? Okay, great. Shurjit, you got it?
So I just didn't get how. So the cancellation part, then you have to be.
Cancellation? What did I cancel?
Not cancel. So after this, sin square A plus cos square A by cos A into sin A. So the next step is cos A
Yeah.
into sin A.
It's basically a rule that we use, like when we were kids. If you remember, we had like A by B divided by C upon D. Do you remember? So do you remember how we solved this? What did we do here?
So we raise
Yeah, we bring C and D up. So it looks something like A upon B into D upon C. We take reciprocal. So notice how the denominator, see, this is the denominator. The denominator's denominator goes up. Do you see? So that's the trick that I'm using. The denominator's denominator will go up. So here, see this one. This is the denominator. And this term is denominator's denominator. So it'll go up, right? You got it? Okay, if you don't understand, go to your basics. So here, what is the numerator? 1. So it'll become 1. This division, I'm converting it to multiplication. So here we have to take reciprocal. So it'll be this divided by this. So it'll be cos into sine divided by cos square plus sine square. You get it now? Okay, good. Let's see question number 3. So we have tan A minus cot A is equal to 1 minus 2 cos square A upon sin A times cos A. Always you have to think what you have, what you need. So what do we have? Tan and cot. What do we need? Cos and sin. Right? So the conversion is going to be same. Let's convert them. Convert this to sin and cos. Convert this also to sin and cos. So tan will be sin upon cos. Cot will be cos upon sin. So this is like the previous sum only. Here if you take the LCM, you get cos A times sine A. This divided by this is sine, into this will become sine square A, minus, similarly here you'll get cos square A. Do you see that we already got the denominator? Denominator was sine into cos. We already got the denominator, cos into sine. Yes or no? The problem is we don't have the numerator. Numerator, see, it's very different. Numerator, we have sine square minus cos square, but here we have 1 minus 2 cos square. You are getting what I'm saying, right? So denominator I'll not touch. Let's see what we can do about numerator. So in the numerator, what do we need? What do we need? What do we need? Again, I repeat, don't look at the numerator as a whole. Just see the trigonometric ratio. Rest follows up. Just look at the trigonometric ratio. What do I need? Cos square. What do I have? And also I have sine square. Do I need the sine square? No. Right? So somehow I have to remove this sine square. And what would be the best conversion? Convert sine square to cos square. Yes or no? So let's convert sine square to cos square. So check your formula sheet and apply the right formula. So there's a formula, sine square is equal to 1 minus cos square A. Yes or no? Right? And then you're left with minus cos square A upon, I'm just going to rearrange this so that it looks like the right hand side. See, now we have only cos square A and we need only cos square A. That means the most difficult part is done. Now we just need to simplify. So I think you got it. What will be the next step? Yeah. What is minus cos square minus cos square?
2 cos square A.
Minus 2 cos square A. Yes or no?
Minus 2, sorry.
Yeah. So cos square and cos square will be added. So you'll get 1 minus 2 cos square A upon sine A times cos A. That's it. That is the right hand side. Proved. Abigail, what do we have? Very good. Okay, you said it rightly. What do we need? Cot. So that means we just need to somehow convert cosec to cot. Alright, but there's a problem. If you see, the problem is that we have a power 4, right? We don't have any formula regarding power 4 in the formula that we have discussed. So what can we do to this power 4? How can we simplify it? There are many ways to simplify. How can we simplify? What do you suggest I should do?
So cosec square A.
It'll basically be cosec square A whole thing square.
Yes, we can do that, right? X to the power 4 can also be written as x square whole thing square. Yes or no? That eliminates the power 4 somehow. So we'll do that. So cosec to the power 4, I can write cosec square A whole thing square minus cosec square A. Good, Tanisha. So now see, we have cosec and we need cot. So convert all the cosec to cot.
1 plus cot square.
Cosec square is 1 plus cot square, right? 1 plus cot square A, and the whole thing square will remain as it is, minus cosec square will convert to again 1 plus cot square A. Remember this, that if you are converting one term into two terms and there is a minus sign before it, you have to put a bracket. If you don't put a bracket, it will be a mistake, right? Okay. So now see, what do we have? What do we have? What do we have? Cot. What do we need?
Cot.
Done. 90% of the problem is solved. Now is just the question of simplifying, whether we know how to simplify or not. So I'm going to go a little bit fast. This is the formula a plus b whole thing square. So this will be a square plus b square plus 2ab minus, if I open the bracket, I get minus 1 minus cot square A. So 1 square is 1. Cot square square. So it will be cot 4A plus 2 ones are 2, 2 cot square minus 1 minus cot square. Now if you simplify it, plus 1 and minus 1 gets cancelled. Here we have cot to the power 4A. 2 cot minus cot will give us just cot. So cot square A. And if you see, that is nothing but our right hand side. Let's see question number 5. Now question number 5 can be very tricky, because if you see, on the left side we have all the possible trigonometric identities, right? Sec, sine, sec, tan. But on the right hand side somehow we just have one, right? It's like somehow everything gets cancelled. So what do we do in this case? The second tip that I like to follow is, if nothing makes sense, convert everything to sine cos. Okay? If nothing makes sense, convert everything to sine cos. Let's convert everything to sine cos. So sec, how can I convert it to sine or cos? Yes, you can see that in the formula list, 1 upon cos. This is already sine, so 1 upon sine. Sec, 1 upon cos. Tan, sine upon cos A. After that, you simplify. So if I open up the bracket here, I get 1 minus cos A minus sine A by cos A. Here if I take the LCM, I get cos A 1 plus sine A. Then here again I can take LCM, so I get cos A 1 minus sine A. 1 plus sine A upon cos A. So does anyone see anything after this step? What should we do? It's a very basic thing, but it's difficult to see in Trigo. Anyone sees anything? Yes. Very good. Do you see that, everyone? This is nothing but the numerator. If you see, it's nothing but A minus B, right? Multiplied by A plus B. So what is the formula of A minus B multiplied by A plus B? Very good. A square minus B square. So what is A in this case? 1. So 1 square is 1 minus B square. So sine. So sine square A. And here we have cos into cos. So cos square A. I know that 1 minus sine square is? Yes. Cos square A. So upon cos square A. And I can simply cancel them. I end up with 1, which is what I needed. So right hand side proved. 6. So the left hand side we have sec square A plus cosec square A, which is equal to, see, the problem with this question is that on the left side also we have sec cosec, on the right side also we have sec cosec. So there is no point of conversion only. Yes or no? So the first rule has gone, that what we need, that you can't follow anymore. So what is the second rule? If nothing makes sense, what do we do?
Converting to cos.
Convert everything to sine and cos. Here, Irene brought up a very good issue. She saw the formula that cos A is equal to 1 upon sec A, or sec A is equal to 1 upon cos A. So she's saying, okay, but there is a square here. The formula does not have a square, right? Genuine concern. This formula works even if there is a square or cube. So just pretend that there is square, so you work in the same way. Okay. So sec A can be written as 1 upon cos square A. Cosec square A can be written as 1 upon sine square A. After that, you take LCM. So LCM will be cos square A sin square A. See, LCM ka rule, what is the rule? This divided by this, whatever you get, multiplied by this. Cos square sin square divided by cos square will be sin square, and sin square into 1, you end up with sin square. Similarly, cos square sin square divided by sin square will be cos square, and cos square into 1 is cos square. Now it's very easy. Sin square plus cos square is 1, we know that. And this one is cos square A into sin square A. Here what do? We write it with different denominators. So we write cos square A multiplied by 1 by sin square A. Notice it doesn't change anything. 1 into 1 is still 1. Cos square into sin square is still cos square into sin square. But 1 by cos square is now sec square A into 1 by sin square is cosec square A. Let's see question number 7. In question number 7, what do you think we should do in the first line?
Convert 1 plus tan square A to sec.
Yes, very good. We can see that we have 1 plus tan square, and that's a standard formula. So instead of 1 plus tan square, I can simply write sec square A. Rest, let's keep it as it is. So sec square I can convert it to 1 upon cos square A into cot, I can write it as cos A by sin A, and cosec square I can write it as 1 by sin square A. How does that help? You will see that all of them will get cancelled. So cos square and cos will get cancelled. Then here you will have 1 upon sin A upon 1 upon sin square A. Then if you follow the basic rules, this division gets converted to multiplication. That means we have to take reciprocal of this. So reciprocal of this is nothing but sin square A. Then sin A and square gets cancelled, and we, what? This is wrong.
1.
Oh, this cos I forgot to write. So cos A, and then sin A and square will get cancelled. I get sin A by cos A. Sin A by cos A is nothing but tan A is equal to right hand side proved.